this video we're going to look at one of your options in the course, which is industrial chemistry. So these are some of the key phrases that we're going to come across in the course of this video, most of which actually probably you are already familiar with, whether it's from your study of chemistry so far, or those of you that are doing biology as well will have come across some of these phrases. The first thing we have to look at is the contribution of chemistry to society. So through your studies over the last 2 years and through junior cert as well, and through transition year even, you will know that chemistry contributes to society in a massive way. Most of the things you do every day, you use something that chemistry has helped to create, whether that be paint, especially these days when we're all meant to be painting the back of our house or our garden shed. Plastic, okay, so even the plastic that makes your credit card is made through chemical means, through chemistry. Of course, the drugs and pharmaceuticals industry is massive. Petrol or diesel to put in your car, the refinery of crude oil, and also through your cosmetics, fragrances, perfumes, shampoos, and even now when we're so focused on hand washing, soaps, and so on. So some of the main contributions of chemistry to society would be it provides chemicals, pharmaceuticals, fuels, medicines, and agrochemicals, so fertilizers as well. It provides materials such as plastics, semiconductors, and synthetic fibers, and it provides stable, well-paid employment and contributes to our economy. Okay, so not only does it have an impact on our society, but it also has a massive impact on our economy. Especially in the last 20 to 30 years, there's been a huge focus from our government on attracting foreign companies to our country, and there has been an increase in the amount of science graduates in Ireland. So we have an educated workforce which are attracted here, which attract foreign companies. So one of which would be the likes of Syntex, which eventually became Roche, that had a plant in County Clare, where I'm from. Unfortunately, that has closed down, but it provided stable employment for people for over 20 years. The first big pharmaceutical company that moved here was Pfizer, and they moved to Ringaskiddy in County Cork in 1969. Okay, all of these pharmaceutical companies, whether it's Boston Scientific in Galway, my sister works for Medtronic in Galway, any of these big companies provide huge millions of euro to the economy every year. Okay, so James Muspratt is known as the father of modern chemical industry. He is actually from Dublin. He was born in 1793 and he lived until he was in his 90s, which in those days was no mean feat. Died in England, and he was a chemist and an industrialist. So we're going to come on now to some of our general principles of industrial chemistry. Some of these you will already have heard of, especially if you are doing biology. So the first one we come across is the batch process. So reactants, or your feedstock, are allowed to react for a fixed amount of time with each other inside a vessel known as a batch reactor, and these are under controlled conditions of temperature and pressure, and when that reaction is complete, the product is isolated and your reactor is emptied. Okay, so nothing remains in your reactor. Your reactor is emptied, and your next batch, okay, that's I suppose where it comes from, your next batch of reactants are fed into your reactor, and the process is repeated. In a continuous process, though, feedstock is continually fed in at one end of the plant, and the product is continually removed at the end. There is one other possibility, and this is a semi-continuous process, which is of course a combination of the two. So the first stage would involve a batch process to make the product, and the second stage involves a continuous process where the product is purified using feed from various batch reactors. One example of this, of where this would happen, would be in the brewing industry, so alcohol brewing, or in the manufacture of soft drinks. So your soft drink, first of all, would be produced in a batch reactor, and then the addition of carbon dioxide could be done so by using a continuous process. Okay? So carbon dioxide putting the fizz into your fizzy drinks. There are advantages and disadvantages associated with both of them. Okay, so the advantages of your batch process is that there's low capital costs, so setting up costs are quite low. The same vessel is used though all the time, so and it's easier to cater for slow reactions. Okay, so you can allow a certain amount of time for the reaction to take place. You can leave it and come back. The disadvantages is that they are time consuming and labour intensive, because you have to wait for that reaction to take place fully before you can empty your reactor, and then it's labour intensive because you have to empty that reactor. Contamination is more likely. Okay, so even though you yourself are using the same vessel, if you have various different processes happening inside the same factory, there's potential for contamination to occur between reactors. And it's difficult to control exothermic reactions in a batch process also. Okay, we don't really need to know them in any more great detail than that. And our continuous process then basically the opposite of our batch process. So our advantages is that there are low labour costs because it's driven by computer automation a lot of the time. There's low risk of contamination since there's only one product being made. Long periods of use without stopping for maintenance. And your disadvantages then is that there are high capital costs, less flexibility, and it's not cost effective unless run at full capacity. Okay, so the raw materials then that are used. The reactants in an industrial process are called your feedstock, and your feedstock is produced from raw materials. So your preparation of raw materials for the feedstock involves purification or chemical treatment of raw materials. When we look at our case study in a few minutes, that will be a little bit more clear. The big thing to take away from this is that the reactants in an industrial process are referred to as the feedstock, which are produced from raw materials. Okay, I should add that this is the start of your general Okay, so these are general characteristics of industrial processes, and we're going to look at 10 of them. So the first one are your raw materials or your feedstock. Okay. Your second one then is your rate or your reaction rate. So temperature, pressure, and the use of a catalyst would be considered to achieve a satisfactory rate. So your optimum reaction rate is identified in the context of both economic reasons and your yield. Okay, so we were looking before when we were talking about equilibrium that through the Haber process that they operate at compromise conditions. Okay, so they don't necessarily operate at the conditions that is going to give them the maximum yield, because it would be too expensive for them, so they wouldn't make money off of it basically. So your kind of compromise conditions are decided upon based on economics and the yield that you will get from the process. Okay, your yield then, okay, that we mentioned there. So many factors have to be considered when planning to maximize the product yield. The conditions chosen must be such as to result in a satisfactory yield. How the temperature, pressure and catalyst contribute to the process have to be understood when choosing the ideal conditions. Okay, so here you would be really referring back to your study of equilibrium and how to maximize your yield, but will that cost too much? Maybe to have something at a high pressure, low temperature situation, or high pressure, high temperature. Would that cost too much? Can you make money off it? If you can't make money off it, then you're going to operate at compromised conditions. Okay, but then if your temperature is too low, maybe you won't have any yield, or if your pressure is too low, you won't produce any yield at all, or very little. So temperature, pressure would be the two main ones that would have to be considered. Okay, the percentage product conversion with each reaction have to be considered as well. Whether any reaction in the production process is a reversible reaction, and can unreacted materials be recycled back into the process, have to be considered. So if you're able to recycle, which happens a lot of the time in your continuous process, if it's a reversible reaction and you're able to recycle some of your maybe byproducts or co-products, if you're able to recycle them back into your reaction, well then you're going to have less running costs. Okay, again, what drives everything is economic considerations. So your feedstock preparation, how does that cost? So what has to be done to your raw materials to allow you to have this feedstock or to have your reactants? Your reaction then, your temperature, pressure and catalyst. What are your running costs for each of them? How much energy are you losing? How much energy do you have to apply? At the end you have products, you have co-products and byproducts. How much is it going to take you to separate those? They are all considerations that have to be taken into account. And can you maybe take some of these products and feed them back in if it's a reversible reaction? So your operating conditions, costs, capital, fixed and variable costs. Okay, so fixed costs would be stuff like paying workers. Variable costs are costs and that can vary, so those of you doing business would have more of a knowledge of that. All you have to know for this is that it's one of the things that we consider. Use of energy, the location of the chemical industry. So a lot of the time we'll see that these big industries are located beside rivers or lakes, and that is a way of cooling their machinery. Okay, a cheaper way of cooling their machinery rather than transporting water or transporting coolant. They use water, and also a lot of the time water is used actually in the industrial process as well. And then safety and the environment are also considerations that have to be taken into account. Okay, so energy consumption is a big cost in any chemical industrial process, so minimizing the amount of energy used is a big consideration. The generation of energy on site is favoured. The use of catalysts, so if you use a catalyst, when we looked at our rate of reaction, okay, and if we look at, let's just say we have, let's say we have an exothermic reaction. Okay, so we know that this here would be, whoops, not a very good diagram, but that there would be your activation energy. So you would have to reach that amount of energy for more effective collisions to be taking place. But if we added a catalyst in, that you would start with this line, you wouldn't require as much energy in order to reach that activation energy. So this would be with the catalyst. If you use the catalyst, that's going to reduce your cost and energy. Okay, so recycling of heat would be another possibility, okay, to reduce your energy costs. Then your products, your co-products, are other products made along with the main product. The separation of co-products from the main product and their disposal have to be examined. So are the co-products useful, or do you simply just have to get rid of them? Have you to throw them away? Are they useless, or can you make money off them as well? Maybe you could sell them as well. And your byproducts then are products made from side reactions which reduce the yield of the main product. Okay, and very often as well these byproducts can be sold as well. Okay, waste disposal, so looking after our environment as well, so we're not just dumping huge amounts of chemicals into our waterways, and also then industry that releases carbon dioxide or other emissions into our atmosphere. Okay, and they're continuously monitored. Dust can be removed by electrostatic precipitators, and gases can be removed. Gases can be scrubbed to remove sulfur oxide and grit. Effluent is continuously monitored and treated before it is returned to our waterways. Similar to that we would see when we looked at water treatment and sewage treatment. Similar processes. Okay, maybe our unreacted materials can be recycled, so we don't have to dispose of them at all. And safe disposal of waste materials has to be built into the process, so it's not kind of an afterthought that you come on to afterwards, that it's actually built into your process to begin with. Then we move on to quality control. Okay, so before any products are sold, random tests are taken from different samples of the material that you're making, and that is carried out at every stage of your process. So this may involve wet chemistry techniques, instrumentation, such as IR spectroscopy, HPLC, gas chromatography. Okay, there are lots of examples of that. Okay, big thing then in labs and in the industry, of course, is safety. So the layout of the site and the plant should be examined in regard to safety considerations. Okay, so you want everything to be well laid out, that it's safe, that if there was an accident that people could remove themselves from the area quite easily, that there aren't maybe big build-ups of people in one area at any one time, that people are able to get around the site very easily, that everywhere is accessible to different types of vehicles, and so on. Okay, your staff should have ongoing health and safety training, and personal protective equipment, PPE, which we're hearing so much about at the moment. In this case, you're looking at helmets, boots, goggles, earplugs, protective clothing, maybe face masks. Yes. Okay, and then cost considerations as well. So fixed costs, we came across there a little while ago. So labour, plant depreciation, so maybe how much value your plant is losing in value every year, the actual buildings, how they're losing value, and your machinery as well. Repayment of loans, utility bills. Okay, so factories have to pay electricity companies and phone companies like anyone else. Okay, variable costs then depend directly on the rate of production of the plant, so your cost of raw materials, cost of effluent treatment, your disposal, your distribution costs, so how much it costs you basically to get your product around the country, plant maintenance and administration. Okay, capital costs then is costs involving maybe building new buildings and also buying new machinery. Okay, site location is another thing to be considered. So chemical industries are often established near the source of raw materials or near a market for the product. The local availability of water is usually an important consideration, as is the availability of a suitable workforce. Transport of raw materials and products are also important considerations. Okay, so I think that's pretty self-explanatory. Your construction materials then, again, I think pretty self-explanatory, so I'm going to just let you read that for a second yourself. Okay, and then of course the most important thing is that you actually have people to work in that factory or in that industrial plant. Okay, so employees who are directly responsible for the operation of a chemical plant should be qualified. Okay. Now at this point you should be able to do the following. If you can't do this, you need to go back and look through your notes or look at this video again. Okay, so you need to be able to explain a batch process, continuous process and semi-continuous processes. What are the advantages and disadvantages? Sorry, I should have there as well. So advantages and disadvantages of batch and continuous processes. And can you list and explain some general characteristics of industrial chemical processes and some of the things that have to be considered? And now we're going to take a look at one of our case studies. So in your Chemistry Live workbook, they go through 3 case studies, but you only have to look at one. And the one that we are going to look at is Premier Periclase. Okay, they are located, you can take a look at their website if you want to. They are located beside the River Boyne. Okay, and they are in Drogheda in County Louth. Okay, they specialise in the manufacture of magnesium oxide in their plant. Okay, so it's a continuous process, so we should know what that means at this point. Okay, so magnesium oxide occurs in the mineral Periclase. Okay, so Periclase is a mineral and magnesium oxide occurs in it. Periclase has a high melting point of 2800 degrees Celsius and is used to make refractory bricks, which are heat resistant for lining furnaces. Okay, so they then are often, them refractory bricks are transported to steel making plants around the country. Okay, as they are heat resistant, they can be used in the manufacture of steel. The magnesium oxide powder is made into pellets and into briquettes. Okay, so there is another another thing you can sell from this process. Okay, so you're trying to make as much money as you can and increase your yield. Okay, so the raw materials we have are limestone, so calcium carbonate, and seawater, but the feedstock that we actually put in is calcium hydroxide. Okay, and purified seawater. Okay, this CaOH2 you will recognize as being maybe lime water. Okay, in this case we call it slaked lime. So this is how we prepare raw materials to become feedstock. So seawater is degassed to remove dissolved gases and filtered to remove solids such as sand and silt, and that purifies our seawater. Okay, this purified seawater will form the feedstock to react with the lime water, or your slaked lime. Okay, so you have limestone, calcium carbonate. This roasting, this is basically representing heat, so you have to heat it. Okay, this lime is what we call quicklime. Okay, so it's known as quicklime. And this, of course, is carbon dioxide. Okay, this heating happens in a kiln. Okay, so it's basically just a large oven. Okay, then we have the conversion of lime into slaked lime. Okay, so water is added to the lime that we created in the first stage, and we form a substance called slaked lime. Okay, it has the same chemical formula as lime water. Okay, so slaked lime would be the solid. Okay, a solution of slaked lime then is known as lime water. Okay, the reaction of slaked lime then with seawater to form magnesium hydroxide. Okay, so in the third stage, the calcium hydroxide from step 2 reacts with seawater, and the magnesium chloride found in seawater reacts with the calcium hydroxide to form a precipitate of magnesium hydroxide. Okay, so this is your calcium hydroxide from stage 2, or from the last part. Okay, that then reacts with seawater, and the magnesium chloride found in seawater reacts with the calcium hydroxide to form a precipitate of magnesium hydroxide. Okay, so this is found in seawater. Okay, so seawater, hence there is salt. Okay, so this is a salt. So you have that slaked lime reacting with the magnesium chloride in seawater to form our products. So magnesium hydroxide and calcium chloride. And then if you heat that magnesium hydroxide, if you heat that magnesium hydroxide again in a large furnace to form magnesium oxide. Okay, the magnesium oxide powder is then made into briquettes and heated at 2300 degrees Celsius to make final high density pellets. Okay, so here you're going to have magnesium oxide plus H2O to account for the rest. Okay, to account for these two hydrogens and the other oxygen as well. Okay, so we've looked at characteristics of premier Periclase. So raw materials, so limestone from a local quarry that is nearby, and then you have seawater from the Boyne estuary. Okay, so raw materials are very easy to obtain from the location of which they are. Your feedstock, calcium hydroxide, and purified seawater, so your calcium hydroxide coming from your limestone, and your purified seawater then being made from your seawater from the boyne. The reactants are called feedstock and are produced from the raw materials. If we then look at the reaction rate, the main reaction is actually quite fast. Okay, so you have your magnesium chloride and your slaked lime, and then you have magnesium hydroxide and calcium chloride. So to slow the process down for the formation of large crystals, the incoming seawater is diluted with spent seawater. The reaction mixture is speeded up with magnesium hydroxide, and a high temperature of 900 degrees Celsius speeds up the loss of water to form your magnesium oxide. Okay, so they slow it down to create larger crystals, and then once they have them crystals created, they speed the reaction up again. Your products, so co-products, are products made along with the main product. In this case, calcium chloride is one. And your byproducts then are products made from the side reaction which reduce the yield of the main product. Okay, in this case there are no byproducts. Okay, just in general, the yield of your product, 2 grams of magnesium oxide can be formed from a litre of seawater. Okay, in Premier Periclase, their waste disposal and effluent control, they have dust is being removed by electrostatic precipitators, gases are scrubbed. The UC water contains calcium hydroxide, which is alkaline, and that has to be neutralized to reduce the pH. Okay, it is then filtered to remove suspended solids before being released back into the sea. So if it was too alkaline, the conditions wouldn't be suitable for the marine life to live in. Okay, the quality control they have acid-base titrations are used in analysis of materials during the process, and X-ray fluorescence is an instrumentation technique used to test the purity of the magnesium oxide crystals. Okay, those safety considerations we looked at already, they're very general. Your costs then again are quite general, more or less the same for most places. And your site location. So in this site there's a plentiful supply of seawater from the Boyne estuary. It's located near a local limestone quarry with a good road and rail network for easy transport. Okay, not too far from Dublin port either, so they could potentially export their materials to Britain or to Europe as well quite easily, with their with them being so close to both Dublin port and Dublin airport. There's a highly skilled workforce available, so again they're close to Dublin, they're close to Drogheda, they are close to lots of big hubs of people. Okay, and it was previously a cement factory, so they didn't have to build the site from scratch, it was already existing. They just had to repurpose the site. Okay, so the construction materials, and they have large concrete silos, kilns and furnaces lined with refractory bricks. Many of the buildings are made of steel with outer cladding, and materials that are unreactive and resist corrosion are used, so they are ideal. So the cement factory was an ideal place for them to set up. Okay, this is kind of a flow chart or a schematic of what happens in their plant, if that helps. Okay, it may not, but it may help some of you to visualize what is happening. Okay, and now I would like you to attempt these 2 questions. So this is 2018 question 11. So if you want to have a go at that question, either access it through StudyClix. It's also in a file on Schoology. If you look at examination by units, I think is the name of the folder. Okay, or you could access it through StudyClicks as well. And also question 11 from 2013. And that is the end of our industrial chemistry. Any questions? Please send them on. If something doesn't make sense, okay. A lot of it is quite general, I suppose. But you do need to know what happens at each stage of that process in manufacturing your magnesium oxide. Okay, have a good weekend, everyone.